Hello, this is Britt Caswell with another example video. In this video, I'm covering example 5 from section 5-4 in the SavvasRealize Algebra 1 textbook. The focus of this example is to understand vertical stretches and compressions. So I want us to recall the general form of an absolute value function. Okay, so I have a times x minus h plus k. And so in previous videos, we've already discussed the h and the k. Now we're focusing on this a, which is a number being multiplied to the grouping symbol here. Now that number has three jobs. All right, it's going to either do a vertical reflection. Well, everything here is vertical, so I'm going to put vertical on its own line, right? Because this is done outside the grouping symbol. Okay, so it's going to cause either a reflection, a stretch, or a compression. Okay, those are the words we mean when we talk about stretching or kind of shrinking it down. So you have a reflection when you have a negative number for a. All right, so this negative 1/3 that you see here, that's going to cause a reflection, which is just where the graph flips upside down. All right, now the stretch occurs when the number for a is bigger than 1. So we're ignoring any possible negative sign and we're actually just identifying the value for a. All right, so if it's a 3, you're going to stretch. If it's a 1/2, it's not a stretch. Okay, so if your number, again, ignoring the negative sign, is less than 1, so if it's like 1/3 or 1/2, you're going to have a compression. So it's like you're grabbing the top and the bottom of the graph and squishing it down. All right, so let's take a look at the parent function, which I'm drawing here in black, and compare it to some of these stretches and compressions and reflections we're going to see here. Okay, so again, here in black, this is the original parent function. So now we have a 3x here. Okay, it's positive, so there's no reflection. But that 3 is going to cause a vertical stretch. And so the way that I kind of think about it is I think of it as increasing the potency of any x value that we plug in. So if I plug in a 1, instead of it just going up by 1, now it's going up by 3. It has tripled the rate for which this graph is growing. And if you notice, by tripling that rate, we're increasing the slope. So the slope here is now 3 and -3 for that one, right? Okay, so this is g of x equals 3 times the absolute value of x. And so this is why they call it a vertical stretch, because if I grab this graph, here at the top, that's a hand. Here at the bottom, that's another hand. They're just horrible hands. And I pull from where I'm holding it, it's going to cause the graph to stretch like this. Now here in part B, there's two things happening. There's the negative sign, okay, which is going to cause a vertical reflection. And then there's the 1/3, which is going to cause a vertical compression. So not only am I flipping the graph upside down, but I'm grabbing it at the tops and the bottoms and I'm squishing it. So instead of the rate tripling, it's going to go down to 1/3. Another way to think about it is here on the right hand side, instead of the slope being 1, the slope is now going to be -1/3. And so what that looks like in terms of graphing is like this. So notice that the graph is a lot wider and also upside down. All right, so there we have it. That is understanding vertical stretches, compressions, and I'm going to sneak in there and reflections. Until next time.